That's a different concept, but if you can just, while you're at it, just give a few words to explain it, and if quantization is ever involved in it or not.
Yeah, it's basically a process of taking a larger model, which we call a teacher model, and a smaller model, which is called a student model. And then we fine-tune both of them. We fine-tune the smaller model by just trying to teach the smaller model how to produce the same outputs that the larger model produced. So you take input batch, you pass that through a larger model, you get some target outputs, and then you take the smaller model, you do the forward pass with the smaller model, and then you compare that and see, how similar my outputs are to the outputs of the larger model. If they're dissimilar, okay, let's optimize to be as similar as possible to the outputs of the larger model.
So that's like reinforcement learning.
Well, yeah, I guess you can look at it, except that you don't have all this verifiers, feedback loops, and so on. I mean, one feedback loop is the loss that you're getting. It's just that in the standard setup, when you're fine-tuning, you're usually optimizing for cross-entropy loss, right? So you have one, like a golden label that you just want to predict. Whereas when you have a teacher, you actually get the full distribution on the outputs. And then you try to match that distribution of the teacher.
And it's up to you, like, when do you realize it's over? It's like at the end of the train, like the distillation. Is there a limit, or is it like it's up to your samples or inputs?
It's up to you. It's standard fine-tuning process. It's literally just the loss function that you're optimizing is slightly more complex now. Yeah, nice. That's the only difference. Yeah.
Right, so it could be days, it could be hours. It's up to you.
Yeah, I mean, it's definitely more expensive because instead of just training one model, now you have to load the teacher, and you have to do forward pass through a teacher, which is usually a larger model. So you have to pay additional cost in terms of the runtime and GPU memory. Yeah,
got you. But once you're done, the distilled model is like super small compared to the original, right? So like you can have the DeepSeek Air 1 and just apply it anywhere eventually.
Yeah,
I mean, like distill it on the Llama.
If you have resources to run the training with such large model. One special case where we saw the distillation being very useful is in producing the 2-4 sparse models. We have like the problem with, so the good thing about quantization is that you can do it in one shot. So you train a model, at the end you quantize, do this like post-training quantization. You do it, as Colin said, in a couple of minutes, you have like really good high quality model. Whereas with sparsity, this is not going to happen. If you do 2-4 in this like one-shot regime, like the model is going to collapse completely. It's really hard because you're removing like 50% of the weights at each layer. So for sparsity, you always need to do a little bit of fine-tuning. And where knowledge distillation really helps, for example, in this case, you take Llama model, 8B, you do 2-4 pruning, and then you fine-tune it with unpruned, like the original Llama model, and then you distill the intermediate activations. So you train a smaller model, which is now 2-4 sparse, to follow the activations of the original unpruned model. And this gets you like a really, really good model. That's, for example, how we released the sparse Llama 3 8B model. We did literally pre-training by following this approach. Like we had some like distillation scheme where we would distill all of the intermediate activations from unpruned model.
So like you took a teacher model like a 405B or something?
You can take whatever you want. It's just a matter of the cost, whether you can run such large model during training, and how do you map activations of a larger model into activations of a smaller model, because usually they have different shapes, right? If you take the models of the same size, the intermediate shapes are all the same. If you take 405B, then you have to have some intermediate mapping from the large space of the larger model into smaller activation space of a smaller model.
Yeah, because the parameters are, it's
number of parameters is different. There's more layers, like 3 times more layers. Yeah, it's very easy when it's like one-to-one. You just like map each layer to each layer. Whereas if it's larger, then you have to think a bit more about it.
Map it. All right. But there are people doing it. Like people are distilling. Like those who have the means. I mean.
Yes.
In the basement.
Of course. Yeah. I mean, it's like very, very. I think it's probably the only way right now to produce high quality sparse models. There is no other way to do it. Yeah.
Nice.